Hello, good evening, friends. Welcome to the YouTube channel of Creative Edge, one of the subsidiaries of Top Ranker. We are talking on our series of Aram, and I'm going to take an interesting subject today, namely color theory, which is foundation of for UCEED, NID, and NIFT, even for architecture entrance test preparation. So what is this color theory all about? In fact, if you talk me today, it will be only one part of the total color theory you should know about um, while facing a competitive exam. Friends, my name is Rajendra Bhatia, and I have been into this field for a pretty long time. And let us get on with the color. So, what is color? Color is what the human eye see when light is reflected off an object. When light shines on an object, some colors bounce off the object and others are absorbed by it. Our eyes only see the colors that are bounced off or reflected. Friends, the sun rays show all the colors of rainbow mixed together. This mixture is known as white light. When white light strikes a white object, it appears white to us because it absorbs no color and reflect all the colors equally. A black object, on the other hand, absorbs all the color equally, like the one I'm wearing right now, and reflect none. So it looks black to us. Going further, let's see what is happening with the sun rays. Sun rays is not simple. On other hand, it is very complicated. It has got bands and bands and bands of electromagnetic waves, namely cosmic rays, gamma rays, X rays, ultraviolet rays, then the visible spectrum of light, which we see as seven colors. However, originally there are three colors only. Rest of the four colors are the mix of these three colors. And what are those three colors? Red, green, and blue, RGB. And that ranges between 400 nanometer to 700 nanometer. Then comes the name of infrared rays, microwaves, short radio waves, long radio waves, medium radio waves. And what is light? What is light? Light or visible light is electromagnetic radiation within the portion of the electromagnetic spectrum. That's what we saw. That can be perceived by the human eye. All these electromagnetic waves cannot be perceived by human eyes. You must have seen doctors working with X-rays. Where can you see X-rays? Or infrared radiations? Or what we really suffer with, like if you go in bare body into sunlight, and particularly this summer days, you get a skin burn because of the ultraviolet rays, invisible to the eyes, but they are very effective electromagnetic waves. So light is defined as the electromagnetic radiation with wavelength between 380 and 750 nanometers. But what is visible to the human eye? Visible light has wavelength in the range of 400 to 700 nanometer only. Here is another graphical presentation. Red color, wavelength 700, and likewise you go to the orange 600, yellow 580, green 550, blue 475, 450 is indigo, and 400 are the violet rays. So how do we perceive the color? As strange as it sounds, objects themselves don't have color. They have properties that determine which all wavelengths of the light are absorbed and which are reflected. बड़ा फनी लगता है ये कि this object, my t-shirt, hasn't got its own color. It has got properties to absorb all the colors. So none is reflected. None is reflected. That means this is seen as black. Similarly, take an example. Think about a red car under a street light. All the colors from the halogen light are shining on it. Or what are those, all the colors? RGB. Yet we only see red. That's because the red car's paint absorbs the green and blue rays of the white light and reflects the red. When you look at the car, your retina inside the eye perceives the reflected red light and sends a message to the brain. Oh, this car is red. Take an example of a cyan ball. Cyan is a kind of blue color which when prepared, it is prepared with a mixture of green and blue. So it's that green or that blue color, cyan. Now you think of a ball made up of cyan color. Let's take okay, let's say that this is a ball of cyan color. That means it has a property of reflecting cyan color. White light coming to it, white light comprising of blue, green, and red. What will happen? The red will get absorbed inside that paint, and green and blue will be reflected by this cyan object. Now that travel towards our eye and enter the pupil of eye. Now both of them are entering the eye. What happens inside the eye? There's a double convex lens here. The pupil let the two color enter here. From the convex lens, the color is distributed on the retina. Retina has got two kinds of cells, rods, and these three are different variety of cones. Rods are responsible for the tonal values. That means white to black color. And the cones are individually responsible for either the blue light or the green light or the red light. Now, when we see this situation, what is happening? Red is not coming to the retina at all. Only the blue and green color, which activate the cones of respective colors. And this is conveyed to the brain through a nerve called as optic nerve. Now, this optic nerve takes the impulses from retina and convey it to the brain in the area of the brain called as optic lobe. Now, these are two colors. Let me correct this. Green and blue reaches optic lobe of the brain. Brain cannot recognize two colors separately, these two colors separately. So what happens? Like again, it mixes up the blue and green, and the perception is cyan. Perception is cyan color. So starting from the cyan object, cyan colored object, how the white light work is, this is the physiology of working of perception of the light and the color. If we look into the history of light or the color wheel was first invented by the same gentleman, Isaac Newton, who mapped the color spectrum. Now, same in the sense he's the one who also brought in the theory of gravity and so on and so forth. So he mapped the color spectrum onto a circle. The color wheel is the basis of the color theory because it shows the relationship between the colors. Now, if we have to study the color, we have to study two color wheels, additive color wheel and subtractive color wheels. So far, what we know are the color pigment. Color pigment, subtractive color, because pigment, light coming to it, reflect certain electromagnetic waves, and out of the three waves it has received, three colors it has received, RBG, okay, or RGB. Now, when it is absorbing the rest of the color, that is why it becomes a subtractive color theory or V. And when we talk of the light, then we are talking about additive color wheel. Let us see them to be more practical. Additive color theory, that means basic colors are red, blue, and green. The RGB, when individually red and blue are thrown, let's say, in an empty place, then you get a mix of these two colors. You get magenta. If you have got green and blue together, then it becomes cyan. And when you have got red and green, very strangely, you try it with subtractive color, you may not find yellow happening with this. But with the lights, it will happen. Quite similar to what we know since our childhood. Your school drawing teacher said, mix all the color, you will get white. In physics, there is an experiment where all the colors are there on a disk and you run the disk pretty fast. You get what? The disk get converted to white color. Okay. So that is what is happening when you throw yellow, magenta, and cyan equal potency into the center, you get white light. Subtractive color theory, that means the color theory of pigment. Here the primary colors are red, yellow, and blue. Now, nowadays they have started counting more specific which red, which blue, and which yellow are primary color. So among the red, it is the magenta among the subtractive color. Blue, it is the cyan. And yellow, it is the cadmium yellow. So they are the primary colors of among the subtractive color theory. And you know that when red get mixed to yellow, or in other words, magenta get mixed to cadmium yellow, it gives you orange. When red get mixed to blue or magenta get mixed to cyan, you get violet. And when cadmium yellow get mixed to cyan, you get green. That is the phenomena of subtractive color. And when they are mixed together, they tend to go to black, depending on the hue value. So let us also talk about two types of color theories. Color vision in human is based on the additive color theory only. That means the reflected light that you receive in your eyes. This theory states that all the perceivable color can be made by mixing different amounts of red, green, and blue. Light, of course, the primary colors of the additive color system. Equal amounts of three primaries give the sensation of white, while the absence of additive color gives you the sensation of black. Subtractive color, when we mix color using paint or through the printing process, we are using the subtractive color method. That means subtractive color mixing means one begins with white and ends up with black. As one keep on adding the colors, result get darker and darker and tend to go to black color. Color classification based on subtractive color, that means the pigment color. They are the primary color, secondary color, tertiary color, warm color, cool color, complementary color, split color, analogous colors. There may be few more to understand the colors. Primary color, which cannot be made by mixing any two colors. Example are red, yellow, and blue. Secondary color, which are formed by mixing any two primary colors. The examples are green, orange, and violet. Green, orange, and violet. Tertiary color. These are a mixture of any two secondary colors. The secondary colors are violet, green, and orange. So if you mix V plus G, you get a tertiary color. O plus V, you get a tertiary color. Green plus orange, you get a tertiary color. You further analyze it, it is RB plus BY. That means you are actually mixing two BYR, two blue, one yellow, one red. Similarly, R plus Y, R plus blue, two R, YB, Y plus B and Y plus R, two YBR. As we see above, the resultant are two RYB, two BYR, or two YBR. All have BYR common. That is the primary color are present in all the tertiary colors that you can obtain. Hence, tertiary color could also be called as mixture of all the three primary colors. The inference is mine. Further analysis of secondary color also reveals that all the secondary color contain two primary color. A third one can be mixed to obtain the tertiary color. That means in green, which contains B plus Y, you need to mix red to get a tertiary color. Similarly, orange, R plus Y, you mix blue into it, you get tertiary color. Violet, B plus R, you mix yellow into it and you get a tertiary color. Hence, tertiary color is a mixture of secondary color and a missing primary color into that secondary color. Some qualification on the basis of properties like hot or warm color, cool and neutral colors. They can be classified as hot and warm colors. Hot or warm colors are the ones which give a feel of warm by looking at them. What are those colors? Examples are yellow, orange, and red. As they remind of sun and fire. Cool colors similarly, which give a feel of calm and cool. Violet, blue, and green are as they remind of water and grass. Neutral color means no color, but technically they do have some color into them. For example, white, beige, tan, brown, gray, taupe, and black. These are all neutral colors. This is a chart which may give you a neutral color at a glance. Now I want to also give you some glimpse of color harmonies. That means mix of the colors or color used together give you a pleasing and aesthetically beautiful picture. That is what is termed as color harmony. Different color harmonies have been identified using many color combinations and finding the reasons of causing attraction to the human eye. Now, this is very important for all the design aspiring students to know. Now, in this beautiful chart, all the color harmonies, more or less, are depicted. In this color wheel of 12 colors, That means mix of the two color, the basic color is also there. There are 12 colors altogether. What all harmonies can you see? Warm color as I described you, yellow, orange, and red. Cool colors, violet to green. These are cool colors. So that means if in a picture you have used all these colors separately or mixed to each other, that arrangement would be called as cool color arrangement. If you have used color between the reddish violet to yellow, that means reddish violet, red, red orange, orange, yellow orange, yellow. All these colors are warm or hot colors. Then there are other harmonies known as complementary, analogous, monochrome, triadic, split complementary, tetradic, and square. In a brief, I will like to explain you from here only as to what all these color harmonies are there, and they are useful, by the way, in the competitive exam. Complementary color, that means opposite color on the color wheel. Given example is as is orange to blue. Similarly, as is green to red or yellow to violet. These are all complementary colors. Analogous color are three continuous color on the color wheel. Monochromatic. Mono means one or single. Chroma means color. So the tints, shades, and tones of one color, if used in a picture, as you quite um, oftenly see black and white picture or beige and brown picture, those are called as monochrome arrangement of color. So there they are using tints, that means mix of white, shades, that is mix of black, and tones, that is mix of gray in one color. The arrangement is called as monochromatic. Triadic color. If you have got an equilateral triangle placed on this color wheel, wherever are the vertices falling, if those colors are used in a color scheme or in a picture, then that picture would be called as a picture made with triadic color. Now, it is not necessarily that you place the equilateral triangle only on these colors. You could also shift it a little this, so you would get blue, you would get yellow and red. So if you use red, blue and red, yellow and blue in an arrangement, in a picture, in a drawing, then that would be called as triadic arrangement of the color. Now this could be a question in NIFT. Use only triadic color in the two-dimension design that you have made. Or use only complementary color. Use only monochromatic colors. What is a split complementary color? You know the complementary color? Opposite color on the color wheel. Split complementary color are the side by color of the complementary color of the given color. This is yellowish green here, and it is greenish blue here. So these are yellowish green and greenish blue are split complementary color to red. Giving you another example, greenish blue and indigo or bluish violet are split complementary color to orange. Tetradic. Now the definition is little complicated. Many of even teachers fumble explaining tetradic. Tetradic is an arrangement of four colors. Those are the pair of split complementary color of one pair of complementary color. They are the split complementary pair of opposite split complementary color of one pair of complementary color. Take example of again red and green as complementary color. Their respective split complementary color are yellow green, greenish blue, reddish orange, and reddish violet. So the pair of yellowish green and reddish violet and the pair of orangish red and greenish blue. That is what is here. So that is tetradic. Now square color, when you have a square placed on a color wheel of 12 color, wherever are the vertices falling on the color wheel of the square, that set of four color will be called as a square color. To give you another example, suppose you move this over here. So what will be square color of this? This one, and this one. That will be the square. That means blue, yellowish green, orange, reddish violet. That set of four color will again be square color. And likewise, you can find out somewhere around 3 or 4 combination of square colors. That's about understanding the colors. This is once again just for the interest of student. We have presented another graphics of complementary color and split complementary color. As I told you, split complementary color are the side by color of the complementary color of the given color. Analogous color, although was explained as side by color, 3 side by color to each other. However, true speaking, analogous color in subtractive color wheel, that was of the additive color wheel. Here you can understand analogous color is a scheme of color wherein 2 secondary and 1 primary color and their tint shades and tones are used in such a way that the primary color is present in all of them. Here are 3 examples of it. Yellow, orange and green. Orange contains yellow, green contains yellow. Blue, violet and green. Violet contains blue and green also contains blue. Red, violet and orange. Violet contains red and orange also contains red. So that was a part of the color theory. You want to know more about it? Please write to us. If you want to really contact and talk, call us on 6363286363. You want to follow, subscribe to our channel? Here are the media platform where you could link with us. Thank you very much for being with me. I'm sure this has found some interest and definitely add to your preparation of competitive exam. Thank you. Bye bye. Somebody informs me that JBR 2 is out. Yeah.